everyone. In this session we'll see a problem on limit. A problem is limit as x tends to 0 of 1 upon x square minus 1 upon sine square. So this will solve again. So first we'll check which indeterminate form it is. That is, we'll consider this limit as let k is equal to limit x tends to 0 of 1 upon x square minus 1 upon sine square of x. If I apply x is equal to 0, so 1 upon 0 is infinity, minus 1 upon sine of 0 is 0, 1 upon 0 is again infinity. So infinity minus infinity form it is. So we have to make arrangement first, then we can apply forward here. Either we have to bring the situation to 0 by 0 form or infinity by infinity form. So therefore we'll go for the simplification. So simplification is nothing but here we need to take the LCM. So if you take the LCM, so LCM is x square into sine square of x. So cross multiply. So sine square of x minus cross multiply, it will become x square. So now you check, sine of 0 is 0 and 0. So it is 0, 0, numerator, denominator also 0. And now it is converted to what here? 0 by 0 form. But before applying the this one L-Hospital rule, I want to make arrangement to eliminate some standard results with as 1, so that we can make it as, so this sine square x minus x square will keep as it is, so x square, then sine square x as it is, so divided by will make square and divide and multiply x square, so which will be we can write it as limit as x tends to 0, so it will be x sine square x minus x square divided by, so this x square I will write it as x raised to 4 into I will write this separate as limit x tends to 0, so sine square x upon x square, it will become reverse, so x square upon sine square x. So therefore again, so k is equal to limit x tends to 0. So this situation what we have, this is identical like a limit of x upon sine x as x tends to 0. This is a standard result and the result is 1 for this. So left part is sine square x minus x square divided by x raised to 4 into 1. Now check, so this y it is 1 as per the standard limit identity. So therefore again if you apply x tends to 0, so 0 minus 0 is 0 upon 0, so it is 0 by 0 form. So now I can go for L-Hospital rule now. So what L-Hospital rule says here, so by L-Hospital's rule, so numerator differentiation separately and denominator separately, so limit as x tends to 0, so derivative of sine square of x will be 2 sine x and differentiation of sine x is cos x minus differentiation of x square is 1, okay, then differentiation of x raised to 4 is 4x cubed. Now we check again, so if I apply x tends to 0 for this, so sine 0 is 0, so 0 minus, so x square, differentiation of x square is 2x, here make it correction, differentiation of x square is 2x. So if I replace x is equal to 0, so 0 minus 0 is 0, 0 upon 0, again it is 0 by 0 form, so that I can again go for L-Hospital rule. By L-Hospital's rule, so k is equal to limit x tends to 0, so 2 outside, so we need to apply product formula. I will keep sine x as it is, differentiation of cos is minus sine x plus keep cos x as it is. Differentiation of sine is cos x, close it, minus differentiation of 2x is 2, divided by differentiation of 4x cube is nothing but 12x square. So first rearrange everything, then we can think of applying the limit. So limit x tends to 0 as it is. So if you open the bracket, so mine 2 times minus sine also. So sine into minus sine is what here? 2 times minus sine square of x. So 2 times plus 2 times cos square of x minus 2 divided by 12x square. So here I will go some corrections. Otherwise, if you again apply L hospital rule, so again it will become a little bit complicated. Means differentiation of this, differentiation of this. So what I will do here. So before applying L hospital rule, I will make this 2 sine cos x as sine 2x formula, so that it will be easy. So that part I will do here. Just see. So this I will write it as limit x tends to 0. So 2 sin x cos x, I will make it as sine of 2x minus 2x divided by 4x cube. So if you apply x is equal to 0, so 0 minus 0 upon 0, so it is 0 by 0. So by L Hospital's rule, so what happens here? It will become limit x tends to 0. So differentiation of sine 2x is cos of 2x into 2. I will write 2 before, minus differentiation of 2x is 2 divided by differentiation of 4x cube is 12x square. So it will be easy for next level. So now if I again apply x is equal to 0, so cos of 2 into 0, again it is cos 0 is 1, 1 into 2 is 2, so 2 minus 2 is 0, then again 0 square. So again, so we can make this one as, again by L Hospital rule, again it is 0 by 0 form. So take 2 common, it will cancel with this 12, it will become 6. So I'll write the step as, so by L Hospital's rule, so it will become limit x tends to 0. You can take 2 common and simplify, or else first we will differentiate. So 2 as it is, so differentiation of cos 2x is minus sine of 2x into 2, and differentiation of minus 2 is 0 leave it divided by so 24x. Or I will not go for this. So this can be written as, you take 2 common among this, so limit x tends to 0. If you take 2 common, it will cancel. So we have left with cos of 2x minus 1 divided by 6. Okay, so it will become 6x square. So this 2 common, so 2 1 the 2 6 the, so it will be, so cos 2x minus 1, as per the identity I want to write, so I will write k is equal to here, so limit x tends to 0, so this will become cos 2x minus 1 is nothing but, so it is minus 2 times sine square of x divided by 6x square. So by as per the trigonometric value, so cos 2x minus 1 is nothing but minus 2 sine square of x. Okay, So on simplification, so this again I will write it as, so k is equal to limit x tends to 0. So this minus I will write before, so 2 ones are 2 3s are, so it will become 1 by 3 into so I'll write here sine square x divided by x square, so which I'll write it as, or k is equal to minus 1 by 3 limit x tends to 0. So sine square x upon x square, I'll write it as sine x upon x whole square. So as per the limit identity, the limit of sine x upon x as x tends to 0 is always 1, so 1 square. So it will become k is equal to minus 1 by 3 into 1, which implies, so k is equal to minus 1 by 3. So this is the solution of the given limit. So here we have done slight changes in the result while performing, so just note down those things.